Service conductors are not allowed to change size along the run. The electrical code mandates that service conductors must maintain the same size from the service point all the way to the service equipment. Consider a scenario where you have a service entrance. The conductors bringing power from the utility to the building service equipment are the service conductors. The code requires that these conductors be of a consistent size throughout their entire length, from where they connect to the utility supply, which is the service point, to the main disconnect or service equipment inside the building. The reason for this requirement is primarily safety and ensuring adequate capacity. If the conductor size were allowed to decrease mid-run, it could create a bottleneck, limiting the amount of current that can safely flow to the service equipment. This could lead to overheating of the smaller conductor, posing a fire hazard. Additionally, it could compromise the ability of the electrical system to handle the intended load, potentially causing voltage drops or equipment malfunction. The service point is defined as the point of connection between the serving utility and the premises wiring. The service equipment is the necessary equipment, usually consisting of a circuit breaker or switch and fuses, and their accessories connected to the load end of service conductors to a building or other structure. It is the main control and means of cut-off of the supply. Now let's explore the implications of this rule in practical terms. Imagine a residential service where the calculated load requires a 200 amp service. According to the applicable tables in the National Electrical Code, such as Table 310.16, you might initially consider using 4/0 American wire gauge copper conductors to feed the meter. The code dictates that from the point where these conductors connect to the utility's service drop or lateral at the service point, all the way to the main breaker in the service panel, the conductors must remain 4/0 American wire gauge. You cannot reduce the conductor size to, say, 2/0 American wire gauge after the meter, even if the 2/0 American wire gauge conductors appear to be adequately sized for the load connected downstream of the service equipment. This is because the code prioritizes uniformity and consistency in the service conductors to prevent overloading and ensure a safe and reliable electrical system. There are specific requirements outlined in the National Electrical Code (NEC) that further elaborate on the proper sizing and installation of service conductors. Section 230 covers service entrances, and within that section, there are subsections that address conductor sizing, protection, and grounding. These requirements are designed to ensure that the service conductors can safely carry the intended load and withstand any potential fault currents. It's important to note that the ampacity of a conductor, which is its current carrying capacity, depends on several factors, including the conductor material, insulation type, and installation conditions. The NEC provides tables, such as Table 310.16, that list the allowable ampacities of different conductors based on these factors. When selecting service conductors, it's crucial to consult these tables and ensure that the chosen conductors have an ampacity equal to or greater than the calculated load. In situations where the calculated load is close to the ampacity of the initially selected conductors, it may be necessary to upsize the conductors to provide additional capacity and prevent overheating. This is especially important in installations where the load is expected to increase in the future. Furthermore, the NEC requires that service conductors be protected against overcurrent using fuses or circuit breakers. The overcurrent protection device must be sized to protect the conductors from damage due to excessive current flow. The size of the overcurrent protection device should not exceed the ampacity of the conductors it protects. In the case of service conductors, the overcurrent protection device is typically located in the service equipment, such as the main breaker in the service panel. This breaker is designed to trip and interrupt the flow of current if the current exceeds the breaker's rating, protecting the conductors from overheating and potential fire hazards. In addition to conductor sizing and overcurrent protection, the NEC also addresses the grounding of service conductors. Grounding is essential for providing a low impedance path for fault currents to flow back to the source, allowing the overcurrent protection device to quickly trip and clear the fault. The NEC specifies the types of grounding electrodes that are permitted, such as ground rods, metal water pipes, and concrete encased electrodes. It also specifies the size and type of grounding conductor that must be used to connect the service equipment to the grounding electrode. Proper grounding is crucial for ensuring the safety of the electrical system and protecting against electric shock hazards. In summary, the electrical code does not allow service conductors to change size along the run. Service conductors must maintain the same size from the service point to the service equipment. This requirement is in place to ensure safety, prevent overloading, and maintain the integrity of the electrical system. When selecting service conductors, it's important to consult the NEC, consider the calculated load, and ensure that the conductors have adequate ampacity and are properly protected against overcurrent. Additionally, proper grounding is essential for providing a low impedance path for fault currents and protecting against electric shock hazards. Let's clarify some common misconceptions about service conductor sizing. One misconception is that the service conductors only need to be sized to handle the connected load. While the connected load is a primary factor in determining the required ampacity of the service conductors, it's not the only consideration. The NEC requires that the service conductors be sized to handle the calculated load, which includes not only the connected load but also any anticipated future load growth. Additionally, the NEC requires that the service conductors be sized to handle the potential fault current that could flow in the event of a short circuit or ground fault. This is because the service conductors must be able to withstand the high currents that can occur during a fault without overheating or being damaged. Another misconception is that it's acceptable to use smaller conductors for short distances if the voltage drop is within acceptable limits. While voltage drop is an important consideration in electrical design, it's not the sole determining factor in service conductor sizing. The NEC requires that the service conductors be sized to handle the calculated load and the potential fault current, regardless of the distance they run. Even if the voltage drop was acceptable with smaller conductors, it's still not permissible to reduce the conductor size mid-run. To further illustrate the importance of maintaining the same size service conductors throughout the run, consider a scenario where a building has a 200 amp service. The service conductors from the utility to the meter are sized at 4/0 American wire gauge copper. However, after the meter, the conductors are reduced to 2/0 American wire gauge copper. If the building's load exceeds the ampacity of the 2/0 American wire gauge conductors, the conductors could overheat and potentially cause a fire. This is because the 2/0 American wire gauge conductors are not capable of safely carrying the full 200 amps of current that the service is rated for. In addition, the reduced conductor size could also lead to voltage drops, which can cause equipment malfunction and reduce the efficiency of the electrical system. The NEC requires that all electrical work be performed by qualified individuals who are knowledgeable about the code and have the necessary skills and experience to perform the work safely. When it comes to service conductor sizing and installation, it's crucial to consult with a licensed electrician to ensure that the work is performed in accordance with the NEC and local codes. A qualified electrician will be able to accurately calculate the load, select the appropriate conductor size, and install the service conductors in a safe and reliable manner. Moreover, the NEC is a complex and ever-evolving document. It's essential for electricians and other electrical professionals to stay up to date on the latest code changes and interpretations. This can be achieved by attending continuing education courses, reading industry publications, and participating in professional organizations. By staying informed about the NEC, electrical professionals can ensure that their work meets the highest standards of safety and quality. In conclusion, the rule prohibiting the change in size of service conductors along their run is a fundamental safety requirement in electrical installations. It ensures that the electrical system can safely and reliably handle the intended load and potential fault currents. By adhering to this rule and other NEC requirements, electrical professionals can help protect people and property from the hazards of electricity. Let's also discuss some related aspects of service conductor installations. Firstly, the physical protection of service conductors is crucial. The NEC mandates that service conductors be protected from physical damage. This protection can be achieved through various means such as using rigid metal conduit, intermediate metal conduit, or Schedule 80 polyvinyl chloride conduit. The type of protection required depends on the location and environment in which the conductors are installed. For example, service conductors that are buried underground must be installed in a conduit that is suitable for direct burial. Secondly, the proper termination of service conductors is essential for ensuring a safe and reliable connection. The NEC requires that service conductors be terminated in a manner that prevents loosening or overheating. This can be achieved by using appropriately sized connectors and terminals that are listed for use with the specific type of conductor being used. The connectors and terminals must be properly tightened to ensure a secure connection. Thirdly, the clearance requirements for service conductors are important for preventing accidental contact with energized conductors. The NEC specifies minimum clearance distances that must be maintained between service conductors and other objects, such as buildings, trees, and ground surfaces. These clearance requirements vary depending on the voltage of the conductors and the location of the objects. It's crucial to adhere to these clearance requirements to prevent electric shock hazards and ensure the safety of the public. Fourthly, the grounding electrode system for service is a critical component of the electrical system. The NEC requires that the grounding electrode system be installed in accordance with specific requirements to ensure that it provides a low impedance path for fault currents. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes, that are connected to the service equipment. The size and type of grounding electrode conductor must be selected in accordance with the NEC requirements. Fifthly, the service disconnecting means is the main switch or circuit breaker that is used to disconnect the service from the building or structure. The NEC requires that the service disconnecting means be readily accessible and capable of disconnecting all ungrounded conductors simultaneously. The size of the service disconnecting means must be based on the calculated load of the service. Lastly, the service overcurrent protection is provided by fuses or circuit breakers that are designed to protect the service conductors from overcurrent. The NEC requires that the service overcurrent protection be sized to protect the service conductors from damage due to excessive current flow. The size of the service overcurrent protection device should not exceed the ampacity of the conductors it protects. All of these aspects of service conductor installations are important for ensuring the safety and reliability of the electrical system. It's essential to consult with a qualified electrician to ensure that the work is performed in accordance with the NEC and local codes. The electrical code is not just a set of rules. It is a comprehensive set of guidelines designed to protect people and property from electrical hazards. By understanding and following the code, electrical professionals can help create a safe and reliable electrical environment for everyone. Furthermore, consider the implications for different types of services. The rules regarding service conductor sizing apply to all types of services, whether they are for residential, commercial, or industrial buildings. However, the specific requirements may vary depending on the type of service and the size of the load. For example, a large industrial service will typically require larger conductors and more robust overcurrent protection than a small residential service. Additionally, the NEC includes specific requirements for different types of service entrances, such as overhead services, underground services, and service laterals. These requirements address the unique challenges associated with each type of service entrance. For instance, underground services must be protected from physical damage and moisture, while overhead services must be installed with adequate clearances from buildings and other objects. Let's now think about situations where existing services are being upgraded or modified. When upgrading an existing service, it's important to ensure that the new service conductors are sized to handle the increased load. This may involve replacing the existing service conductors with larger conductors that have a higher ampacity. It's also important to ensure that the existing service equipment is capable of handling the increased load. If the existing service equipment is not adequate, it may need to be replaced with new equipment that is properly sized. When modifying an existing service, it's important to ensure that the modifications are performed in accordance with the NEC and local codes. This may involve obtaining permits and inspections from the local electrical inspection authority. It's also important to ensure that the modifications do not compromise the safety or reliability of the electrical system. It's also worth noting that the NEC is not the only code that applies to electrical installations. Local codes and regulations may also apply, and these codes may be more stringent than the NEC. It's important to consult with the local electrical inspection authority to determine the specific requirements that apply to a particular installation. The electrical code is a dynamic document that is constantly being updated and revised to reflect new technologies and best practices. It's essential for electrical professionals to stay up to date on the latest code changes to ensure that their work meets the highest standards of safety and quality. By staying informed about the NEC and local codes, electrical professionals can help protect people and property from electrical hazards and ensure the reliable operation of electrical systems.